Hi everyone. Today we're going to learn about the quadratic formula and the discriminant. This is 8.5. This is our last way to solve a quadratic. To solve a quadratic, we can always use the quadratic formula, no matter what. Um, to use the quadratic formula, we must start in standard form. So ax squared, we must start here where ax squared plus bx plus c is equal to 0. And then we identify the a, b, and c, and then we go with the formula. So the formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You do want to know the quadratic formula. This is something you use a lot in your math life, especially once we get to geometry, algebra 2, your calculus, your trig. We do need that formula. So you want to actually memorize it and know it. X is equal to negative b plus or minus the big square root, b squared minus 4ac all over 2a. If you look at it, I want you to see that the axis of symmetry is right here. So the axis of symmetry is within the quadratic formula, x equals negative b over 2a, right? That's the axis of symmetry. The discriminant, which we'll talk about a little bit later, is also a part of this formula. The discriminant, I don't know why it's doing that, is this part underneath. That is the discriminant. So there is the actual quadratic formula actually have pieces of other formulas embedded. All right, nonetheless, to solve using the quadratic formula, we are going to simply identify our A, B, and C term. So A is equal to 2, B is equal to 3, and my C is equal to negative 5. Once I know my A, B, and C term, I'm going to write the formula. Write out the formula. Don't be like, oh, I already know it. I don't have to write it. Write it out. So x is equal to negative b plus or minus the big square root of the b squared minus 4ac, and it's all over 2a. Once you have that, it's going to be a matter of substitution and execution, right? So x is equal to negative 3 plus or minus the square root of 3 squared minus 4 times a, which is 2, times c, which is negative 5. And it's all over 2 times a, which is 2. The important thing is to make sure that denominator stays there till the end. It is the very last thing that you do. So x is equal to negative 3 plus or minus the square root of 9 minus 4 times 2 times negative 5, which is 8 times 5, which is 40. And then it's a negative and a negative. That's going to make this a positive 40 all over 4. So x is equal to negative 3 plus or minus the square root of 49 over 4. So x is equal to negative 3 plus or minus 7 divided by 4. So this can now be broken into 2. X is equal to negative 3 plus 7 divided by 4, like last class, and x is also equal to negative 3 minus 7 divided by 4. So that x is equal to negative 3 plus 7, which is 4, divided by 4. X is equal to 1. And x is equal to negative 3 minus 7, which is negative 10, divided by 4, which is negative 2.5. So there are two solutions to this quadratic, x equals 1 and x equals negative 2.5. Let's go ahead and try out number 2. For number 2, if I look at it, it doesn't look like ax squared plus bx plus c equals 0. So that means I'm going to have to move some things around. Maybe I just minus the 2x on both sides. Make sure I put it in the middle so that 0 is equal to x squared minus 2x minus 3. Now it's going to be a little bit easier. Now that it's in the right form, I know my a term is 1, my b term is negative 2, and my c term is negative 3. And now I'm going to go ahead and write my formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And now I'm going to substitute. X is equal to negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 3. And it's all over 2 times 1. And again, once I know the a, b, and c, I am simply taking that and substituting it into the equation. So x is equal to negative 2, which is a positive 2, plus or minus the square root of negative 2 squared, which is positive 4, minus 4 times 1 times negative 3. Or, you could do negative 4 times 1 times negative 3. 4 3 is 12. Gives me positive 12. And it's all over 2. So that x is equal to 2 plus or minus the square root of 16 over 2. X is equal to 2 plus or minus the square root of 16, which is a number. It's 4 over 2. So now you're going to actually solve. X is equal to 2 plus 4 divided by 2. And x is equal to 2 minus 4 divided by 2. That plus or minus gets split. And so x is equal to 2 plus 4, which is 6 divided by 2. X is equal to 3. And x is equal to 2 minus 4, which is negative 2 divided by 2. So x is equal to negative 1. And there would then be two solutions to this quadratic as well. Now let's go. We're going to do two more together. These have some different scenarios. Go ahead and pause and try. So x is equal to, our a term is equal to 1. Our b term is equal to negative 2. And our c term is equal to negative 4. Because it's already in the right order in standard form. So that now means my x is equal to negative b plus or minus the square root of b squared minus 4ac, and it's all over 2a. So x is equal to negative b, so negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 4, and it's all over 2 times 1. Now I'm going to solve underneath my radical. Kind of got to do that first. So x is equal to negative 2, which is positive 2, plus or minus the square root. Negative 2 squared is 4. Negative 4 times 1 times negative 4 is positive 16. And that's all over 2. So x is now equal to 2 plus or minus the square root of 20. And that's divided by 2. Now comes the tricky part, because the square root of 20 is not a perfect square. Because it is not a perfect square, we can have two things. Either they want us to round it to a decimal, or they want an exact answer. To get the exact answer, that means we need to simplify that square root of 20. That means the square root of 20, let me get that in a whole different color here. The square root of 20, the square root of 20 can be broken into one perfect square and one not. So we have 20, which is 10 and 2. None of those are perfect squares. We have 4 and 5, and 4 is a perfect square. So the square root of 20 can be broken into the square root of 4 times the square root of 5. The square root of 4 is 2, so 2 radical 5. That is the simplified form for the square root of 20 back in the days. So then we have x is equal to 2 plus or minus 2 square root of 5, and that's all over 2. That can be simplified because I know that here this is being divided. So x is equal to 1, really, plus or minus 2 square root of 5 over 2. That 2 can also be divided, so that I really have x is equal to 1 plus or minus the square root of 5, and that's it. So there are two solutions to this. X is equal to 1 plus the square root of 5, and x is equal to 1 minus the square root of 5. And remember, like before, you can see it like that. That's an actual answer. Or you can see it like that with that, because that's another solution. Now, if they do not want it exact, then you can go ahead and change it to a decimal. So that's square root of 20 all the way up here. Give us this in a different color. We are going to go x is equal to 2 plus or minus the square root of 20, which is a number. It is 4 point, let's go with 472. Take it out 3. And that's also divided by 2. So x is equal to 2 plus 4.472 divided by 2. And x is also equal to 2 minus 4.472. And that's divided by 2. So that x is equal to 2 plus 4.472, which equals 6.472, and divided by 2, which is going to give me an answer of 3.4. 236. That's one solution for x as a decimal. Or x is equal to 2 minus 2.472 divided by 2, which is, oh, and you want to do an approximate for these because it's not exact. I had to round it. 0.236 negative. So those are our approximate answers. Perfect, Ms. Reed. All right. So if they ask you for a decimal, you could go this route. If they want the exact, then we have to go that route with the pink. Approximate would be here in the green highlighted color, and the exact would be there in the pink. Both of those are solution. It depends on how they want it. All right, now let's look at number 4. Actually, I want to pause and I want you to try number 4 all by yourself. All right, now that you are back, you would first identify the A term. Your A term is 2, your B term is -8, and your C term is 1. So then in order to solve, our x will be equal to -b plus or minus the square root of b squared minus 4ac, and it's all over 2a. So now we are going to substitute. X is equal to -8 plus or minus the square root of -8 squared minus 4 times 2 times 1, and it's all over 2 times 2. A term is 2. So x is equal to +8 plus or minus the square root of -8 squared, which is 64, minus 4 times 2 times 1, 8, which is 8. And it's all over 4. So then my x is equal to 8 plus or minus the square root of 64 minus 8, which is 56, and it's all over 4. So x is equal to 8 plus or minus the square root of 56, which is not a perfect square. So if they want me to get this into a exact answer, then I'm going to have to, again, simplify the square root of 56. So the square root of 56, let me think of the factors of 56. How do I get 56? That's 8 times 7. 8 is not a perfect square. Maybe 456 divided by 4. So I have 4 and 14. 56. So I am 1 and 4, 3, 4. Nope, not divisible by 9. 56, 16. Let's see. No, not 16. I think it's 4 because this is 2 and 7. So 4 is a perfect square, and I think that is the one of the greatest perfect square factor of 56. So 56 can be broken into the square root of 4 times the square root of 14, which is 2 square root of 14. And then 14, let's see, that's only 14 and 1, and 2 and 7. So, yep, I know that this has been simplified. And so it's 8 plus or minus 2 square root of 14, and it's all over 4. So now I want to think, because they always want to simplify as far as you can go. 8 over 4, 8 divided by 4 is a number. It's 2 plus or minus 2 divided by 4. That's 1/2. So it's still the square root of 14 over 2. So it's 2 plus or minus the square root of 14 over 2. Nothing else I can do there. So this would be the exact answer. But again, if they wanted it as a decimal, when I was here at the square root of 56, then I would use the decimal and then continue down. Let's keep going. The discriminant. The discriminant is b squared minus 4ac. So if you look at the formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This portion under here, under the radical, this portion under the radical is the b squared minus 4ac. If this number is negative, then there would be no solution, because you can't take the square root of a negative number. If that number is 0, then you would end up with one solution. And if that number is positive, then you would end up with two solutions. So in order to use the discriminant to find the number of solution, the discriminant cannot tell you what the solution is. It simply tells you the amount of solutions there are. So let's look at number 1. You would have to find the A term, the B term, and the C term. And then the discriminant is b squared minus 4ac. Let's go ahead and substitute them. So b is 10 squared, minus 4 times 3 times 2. So 100 minus 8 times 3, 24. 24 is going to give us 76. 76 is a positive number. Because it's a positive number, then I know there are two real solutions. That is your answer. That is what they want to know. How many solutions would they have? How many solutions would there be for number 2? Well, A is 3. Nope, I was looking at the last problem. So A is 9, your B is negative 6, and your C is 1. So again, b squared minus 4ac is the discriminant. B squared, negative 6 squared minus 4 times 9 times 1 gives me 36 minus 36, which is 0. That means there is one solution to this quadratic. Sometimes that's all the problem wants to know. It doesn't want to know what the solution is. It just wants to know how many solutions are there. So now let's look at the next one. A equals 9. B is equal to, I don't know why I keep looking at the problem before. There's no rewind. It's okay. So your A term is equal to 1. Your B term is equal to 1, and your C term is equal to 1. So b squared minus 4ac, that's 1 squared minus 4 times 1 times 1. That means 1 minus 4, which is negative 3. Negative 3 is a negative number, so there would be no solution. Because if you put negative 3, the square root of negative 3 in the calculator, you would get an error. There would be no solution. All right, go ahead and try out 2, 5, and 6. 4, 5, and 6. Go ahead and try 4, 5, and 6. Pause and try. All right, now that you're back, you should have your A, B's, and C's. 4 would have been no solution, 5 would have been one solution, and 6 would have been two solutions. All right, that's it for today. I will see you tomorrow. Remember your paper, your pencil. Bring your paper, your pencil, and your calculator. We're ready to work.